We have seen the loudspeaker is not in a position to give very good efficiency. Why? Because the back waves and the front waves are cancelling each other. If we can able to stop the rear waves coming forward and cancelling each other, then the efficiency can be improved. Or otherwise, back waves and the front waves having a 180 degrees phase shift. If this phase shift is avoided, then the efficiency can be increased. So to increase this efficiency, the signal is diverted, signal is stopped by the help of enclosures. We are enclosing the loudspeaker in a box where the rear signal cannot concentrate on the front signal. If it is concentrating, then the signal has to be added. To improve the efficiency of a voice or the sound generated by the cone, the enclosures are made it. These enclosures can called as a baffle. Baffles, different types of the baffles are there. Open baffle, infinite baffle, finite baffle, and so other things are there. We will see one by one different types of the baffles. What are the advantages of this? Baffle types: flat open baffle, finite baffle, infinite baffle, bass reflex baffle, acoustic labyrinth baffle. Coming to the different types of the baffles, first among them is flat open baffle. Whatever the radiation pattern is coming from here, definitely it goes front side, but if it is open this side as well as this side, there may be a chance of the rear waveforms or rear sound waveforms comes towards this side, and then there is a cancellation of the front as well as the back. So this is a little bit restriction takes place for the waveforms which is coming, but not the total restriction is going to be taken place. So this type of the open baffle is normally not used. This is the one more type of the open baffle system, can be called as a finite baffle system. It is a closely bounded on the back side, but still it is opened in the back side. And the front waves moves in this way, and the back waves there is a chance of going towards on a front side and then cancelling each other. The finite baffle definitely restricts the wave from the back side to the front side, but very less. But acoustically we are getting a loss with this. The waves are getting cancelled, and this type of the baffle also not in use. This is a closed baffle, or can be called as an infinite baffle. Why we call the infinite baffle means the back waves which is coming from the back or rear is not going towards the front side, because inside acoustically it is treated, material is kept, whatever the waveforms are coming, it dies there itself, and only in a front waves goes into the front side, and the back waves are not coming and cancelling each other. So that's why this type of the baffle can be a good baffle for giving you an optimum sound. But one more thing is, if we can utilize the back side rear waves also towards the front side, but not for the cancelling, but adding within a front side, that is called as a good baffle. That we are going to see the next item. As I mentioned to you people, that the back waves which is coming from here and the front waves which is coming from here, both should not be cancelled. So it is not in a totally closed baffle. A small vent is opened here, such that the lower frequency waveforms which is coming from here should come out and add within a front waves, because the back waves and the front waves, the difference of 180 degrees phase shift is available. If you can change the phase of the back waves and combine with a front wave, then the sound is added some more, or it will be deducted, the sound will be available. So that's why a vent is placed here so that a lower frequency waveforms can come and join with a front wave of lower frequencies, such that the waves can be added for a higher energy. This type of the enclosure or baffle is known as bass reflex enclosure. What does it mean by the bass, sir? Bass is nothing but a lower frequency waves. So that's why it is called reflecting the lower frequency from the back side to the front side. So the bass reflect enclosure as name has come. This is another type of a bass reflex, or can be called as an acoustic labyrinth enclosure. Means the waveform which is coming from the back side clearly seen here, and it goes and turns and then come out. By the time the phase of the back waves are coming back to a same phase within a front waves. That's why this acoustical labyrinth can make you for a good amplification or good adding, we can call it. So previously the waves, rear waves and the front waves are cancelled. Presently the rear waves and the front waves are adding. We are taking care of only the lower frequencies, not the higher frequencies, because the higher frequency goes to a straight direction. It will not deviate any waveforms at all or in any direction. Only the lower frequency scattered in all directions. So we are taking care of the lower frequency which is coming from the back side and contacting with a front side and adding and giving a more acoustical value for the loudspeaker. These are all the few other type of enclosures which can boost you the lower frequencies and restrict the backside frequency to the front side frequencies here. So this is the another type of the duct open here and duct open here. The lower frequencies goes from here and the lower frequencies goes from here. And similarly here the two loudspeakers has been placed here, and these two loudspeakers, whatever you are getting the rear waves, are not going to the front side at all. So this is known as Helmholtz resonator bass reflex or drone cone inverter. Students, we know that the loudspeaker is going to give the different types of the waveforms from here. As we know that one here, there is a back waveforms are available and the front waveforms are available. So the rear waveform should not come and the contact with a front waveforms. If it is so, means the both are going to be cancelled here. So that's why, see here the baffle is kept in such a way that means the bifurcation is kept in such a way that to the front to and back, all the radiations which is coming from here or all the sound waves which is coming from the loudspeaker is going towards the front side only. There is no movement is taking place which goes to back side or the back is coming into the front side here. So I'll show you how it is. See, all the waveforms are moving in the front only. This is how the baffle is going to stop all the waveforms which is moving front to back or back to front. The previously we have seen the good radiation. Now presently we see the bad radiation pattern here. Why? Because the enclosure for a loudspeaker is in a very small. The waves which is scattered by a loudspeaker is going front side as well as even the back side also. It take a turns because there is no any hurdle is available and the no baffle is available. So these take a turn in the back side here, and the wastage of the wave energy will be available. Meaning all the energy is not going to the front side. A little energy is wasted and to the back side, which is no utilization for the ear. So that's why whenever we are going for the radiation pattern here, the baffle should be chosen in such a way that so it reflects all the front wave towards the front side only. There should not go back side. This is how the radiation patterns looks. Please see. We have seen and understood the three frequencies are generated from the same cone. Means mixing of the three frequencies like low frequency, high frequency as well as the mid frequency. If three are coming at the same time, the clarity of the frequencies are differed, or the clarity of the voice is differed. So if we can able to bifurcate these three frequencies in a three-way, then the clarity can able to give an optimum. Differentiating these three frequencies in a different path and radiating the sound in a three different way is known as crossover network. Normally, the high frequency is bypassed and the lower are getting out, and the lower frequency is bypassed and the higher frequency are getting out, and the mid frequency are band passed and getting out. So when the lower frequency are coming out from the speaker, those are all known as woofer, and mid frequency is known as mid-range as quaker, and the high frequency is known as tweeter. These crossover network help us, can give us the original voices which is recorded at the time of recording. The students, as we know, the loudspeaker is going to give us the three frequencies: high frequency, mid frequency and low frequency. High frequencies are radiated by a tweeter, mid frequency are radiated by a mid-range speaker, and the low frequencies are radiated by woofer. This has been bifurcated in such a way that keeping in a high frequency high pass filter, high pass filter, band pass filter and low pass filter. The three frequencies are bifurcated, and this is giving us only any high frequencies as we keep it here. This is a high frequency, and remaining all other frequencies it will be obstructed. And this is the mid frequency, and it gives neither the low frequency nor the high frequency, it gives only in a mid frequency. And similarly, if you are going for the low frequency, this is called the woofer, and it gives us only in a low frequencies. And if you have taken the total diagram of these three combined here, so in this fashion we get it here. As we have seen, the three frequencies are combining and giving us the output. So this is the low frequency is coming and coming, ending here, and the mid frequency starting from here and ending here, and the high frequency starting from here and then going here. If you combine these three frequencies, and we are able to get it the three frequencies at the same time output, but within a different speaker. But the frequency range you see from the beginning to the ending, it is in a constant. This is in a good way of getting output, and it is going to give us a more clarity, the high frequency different, mid frequency different, as well as the low frequency different. Now you please observe here also, the lower crossover point means where the two frequency bands are meeting. The lower frequency and mid frequency is known as low crossover point. Similarly, the mid frequency and high frequency are meeting in a point is known as high crossover point. The loudspeakers are in a big way is going to give us sounds, but privacy is needed, and only the sound should be heard by one person. Then we take the advantage of headphones. Headphones are the one, the steel metal rod is coming over the head, and the two speakers are provided to the two ears is known as headphones. These headphones can give you a very minimum sound and within a good quality and quantity also. When we are keeping these headphones, no other persons can able to disturb themselves. Students, now we are coming to electromagnetic headphone. The headphones are different shapes will be available, whereas the earphones is in a very small, headphones is not small. It will have in a smaller size as well bigger size also. Now you see the construction process of a headphone. This is the one case, and this is the next case in which the curved permanent magnet D portion is available. This is acting as a magnet as well as cores for a coils which is available. This is called the C1 and this is a C2. These cores are the coils which is wounded within a very fine wire, a very thin wire, a C1 as well as the C2, and is connected in series. When we are provided any voltage to the fluctuations, both act simultaneously. Because we are connected the permanent magnet as a core for this is called as an N magnet, that is called the north pole magnet, and this is called the south pole magnet. We know that whenever the north pole and south pole is available, in between that a strong magnetic fields are provided here. When these strong magnetic fields are available here, then due to this and above the diaphragm which is available here is made up of iron diaphragm, that is a very thin iron is made as a diaphragm. And when this iron is available near the magnetic field, it try to attracts here. Because of the magnetic field which is providing here, because of the cores and because of the coils. Whenever we are providing any voltage to this, either it aids the magnetic fields or it opposes the magnetic fields. It depends upon the signal which you are providing here. Suppose if aids, the more magnetic field comes in between the north pole and the south pole and try to attract this iron diaphragm towards this side. If not aiding is available, means if the lesser magnetic field is available between these two, then it reflects back here. How it is going to be taken place, we'll see practically. Means when the fluctuations comes towards this, it says that the two magnetic fields is aiding, and the fluctuation is moving towards this side, or curvature is moving top side, then it says that it is not aiding. According to these fluctuations here, means according to the voltage which is provided to these two leads here, the fluctuation starts either upside or downside, and then from here the sound is coming out. This is known as electromagnetic headphone. Earphone also comes under the headphone section only. Only for the privacy purpose these instruments are used. But it is not a professional instrument. Whereas headphones are professional instruments, earphones are commercial instruments. It gives us very low output. The quality also very poor. But still we can able to enjoy sound system by keeping the privacy. This comes in a very smaller section. The earphones are fitted in the two ears. Whenever we take the small radio, that is called the transistor, we require a earphone. This is known that earphone which is in a very small in size is known as a crystal earphone. These are all crystal slabs. We have learned what is in crystal slabs here. Bimorphic cells we call it here. This is prepared by an Rochelli salt. And whenever we are providing any electrical contacts to this crystal microcone is going to start mechanically vibration here. And this is called as a plastic container for keeping the crystal slab. This is the diaphragm which is giving us the sound from here. This is a signal which is coming from the amplifier to the earphone. Whenever we are providing any signal to this side, then these signals are coming from here and giving rise a mechanical strength to the crystal slab. This crystal slab start vibrating. When it vibrates, with it a diaphragm also vibrate, and this diaphragm is going to give out the total sound waves at the output. How it is going to be seen here now. We have seen the compression as well as the refraction here. When it is going, it's called as a refraction, and when it is coming, it's called as a compression. When it is coming out, it is going to give us the different types of the waves, which is related to an electrical signal. Means this is also can be called as a transducer. The electrical signals which is coming and going on to a crystal slab, and the crystal slab in turn mechanically movement is taking place front and back, due to which the sound waves are coming out. This is known as crystal earphone. Loudspeaker is a transducer which converts the electrical signal of audio frequency into sound waves of the same frequency. In principle, a loudspeaker is the converse of microphone, and the two instruments perform complementary functions in a sound recording and a reproducing system. A good loudspeaker should satisfy the following specifications. It should have high efficiency, high signal to noise ratio, wider frequency response, low distortion, desired directivity, adequate power handling capacity, and correct matching impedance. Types of loudspeakers: electrodynamic or electromagnetic moving coil type, electrostatic loudspeaker, dynamic or permanent magnet moving coil loudspeaker, crystal or piezoelectric loudspeaker, and lastly ionic loudspeaker. The loudspeakers has been divided into the three parts: acoustically and mechanically. Those are all in this way. The electromagnetic part consisting of voice coil and a field magnet. It is also called a transducer. The mechanical part on which voice coil is mounted. This part is set into motion when audio frequency of electrical signals is applied to the voice coil. The acoustic part, which transmits the sound energy developed by the mechanical part. The main three parts of a loudspeaker are permanent magnet, moving coil, and diaphragm. Baffles. There is air on both sides of a cone, the front as well as the back. Hence, the cone radiates a sound from both sides. However, when the cone moves forward, there is a compression of air in the front, but a refraction at the back. When the cone moves backwards, compression in the back and a refraction in the front occurs. Thus, the sound waves produced in the rear air are of opposite phase. Phase difference is 180 degrees relative to the sound waves produced in the front. The low frequency sound waves from the rear leak through the sides and meet the sound waves in the front and cancels each other. So, to stop these rear waves, baffle is needed. Baffle types: flat open baffle, finite baffle, infinite baffle, bass reflux baffle, acoustic labyrinth baffle. The loudspeaker is going to give us the three frequencies: high frequency, mid frequency, and low frequency. High frequencies are radiated by a tweeter, mid frequency are radiated by a mid-range speaker, and the low frequencies are radiated by woofer. This has been bifurcated in such a way that keeping in a high pass filter, band pass filter, and low pass filter. The three frequencies are bifurcated, and this is giving us only any high frequencies as we keep it here. and this is the mid frequency, and it gives neither the low frequency nor the high frequency, it gives only in a mid frequency. And similarly, if you are going for the low frequency, this is called the woofer, and it gives us only in a low frequencies. And if you have taken the total diagram of these three combined here, so in this fashion we get it here. As we have seen, the three frequencies are combining and giving us the output. So this is the low frequency is coming and coming, ending here, and the mid frequency starting from here and ending here, and the high frequency starting from here and then going here. If you combine these three frequencies, and we are able to get it the three frequencies at the same time output, but within a different speaker. But the frequency range you see from the beginning to the ending, it is in a constant. This is in a good way of getting output, and it is going to give us a more clarity, the high frequency different, mid frequency different, as well as the low frequency different. Dear students, we have completed the topics of loudspeaker known as directly radiator, horn known as indirectly radiator, crossover network to bifurcate the different frequencies through an tweeter, squawker, and the woofer, baffle for not cancelling the rear waves to an front waves, and lastly headphones and earphones, which is for the privacy purposes and the professional purposes. Hope you understood very well. Meet you again next time.